we can start. So, hello again, everyone. It's my pleasure to welcome you to today's webinar, where we will explore two projects funded by the Horizon Europe program, so the Neutral Path and the Response project. My name is Lise Brusseau. I am working for Dijon Métropole International Relations Department and for the outreach and dissemination of the Response project. First, I would like to thank you for joining us. This webinar is an opportunity to share knowledge, insights, and lessons learned from two pioneering initiatives focused on positive energy district and so PEDs and positive and clean energy districts, the new generation of project represented by the Neutral Path project. We'd like this session to be as informative as possible for you. So please don't hesitate to ask your questions in the chat during the session, and we'll answer them as we go along if we're ahead of schedule, or otherwise we of course save some time at the end of the webinar. Our agenda will take you through key aspects of Response and Neutral Path projects, starting with an introduction with Cecilia Sanz Montalvillo from CARTIF, from the Neutral Path project, and she will introduce you to the concept of PED and PCED and their crucial role in achieving climate neutrality. We'll then hear about the implementations, the concrete implementation within the project. First, from Zaragoza's experiences with the solar integration in the Neutral Path project with Clara, Lorente, Martin from CIRCE. Then we'll hear about innovative solar energy management system in Turku with Hugo Huerta from Turku University of Applied Sciences, and then lessons learned from Response in Dijon and replication strategies with Hadrien Rouchette from Dijon Métropole. Each presentation will highlight technical insights, challenges, lessons learned, giving us valuable takeaway for scaling up these solutions across Europe. Now I will very quickly give you an overview of the two projects to give you a little bit of context if you don't know them already. So first with the Response project, it takes a comprehensive approach to urban transformation, addressing energy systems, digital tools, and citizen engagement. The project started in October 2020, and it supports 54 partners in 13 European countries, including 2 lighthouse cities, Dijon in France and Turku in Finland. So these are 2 demo sites, demonstration site or implementation sites, which test innovative solutions for the implementation of PEDs. It also supports 6 fellow cities: Brussels in Belgium, Zaragoza in Spain, Botoșani in Romania, Ptolemaida in Greece, Gabrovo in Bulgaria, and Severodonetsk in Ukraine. So these cities will make replication plan based on the experiences of Dijon and Turku. So as you understood, we'll also hear today about the Neutral Path project, which focuses on enabling cities to transition toward carbon neutrality by creating PCEDs. As a response, the project combines cutting-edge technology, urban planning, and community involvement to create practical solutions and reduce emissions while improving quality of life. The project started on January 2023 and brings 25 partners from 6 European countries. It supports 5 cities, Dresden in Germany and Zaragoza in Spain. They are the pilot sites or the front runners in the implementation of PCDs in the frame of this project. And it also supports Istanbul in Turkey, Ghent in Belgium, Vantaa in Finland, which are the fellow cities, which will also follow the examples of Dresden and Zaragoza in the frame of NEUTRALPATH. So that's it for me. Let's dive into the program, and I will first give the floor to Cecilia for an introduction on PED and PCDs.
Thank you, Liz, for this kind introduction. And yes, as you have said, I'm working in CARTIF, and now I'm leading and coordinating NEUTRALPATH project. But before going into the technical solutions or how our different cities have achieved these PV solutions and how they could be replicate them, I wanted to introduce, for those that didn't know yet, what we are talking about when we talk about PET or PCDs. Both projects, NEUTRALPATH and Response, are very similar, have the interventions in the lighthouse cities that could be replicated and in the fellow ones. And Response is oriented to doing this through PETs, through positive and energy districts, and NEUTRALPATH through PCDs that maybe could be the new generation positive and clean energy districts. So firstly, what is a positive energy district? It's a district that produces more energy than consumed and needs, and this energy can be used for another parts of the district, can be storage or whatever, but maybe it's very interesting, the solution to share this energy with other parts of the cities or the districts maybe. And in the PCDs are similarly the same, but more focused on being neutral in carbon emissions. So apart from this consideration of energy, where the next steps could be the environmental. And thinking, of course, in this neutrality that our cities, next slide, please. Our cities could have or should have thinking in these commitments with the Commission on it. So this climate neutrality is helped by our PETs and our PCDs, because we used for these districts clean energies. We use this positiveness of the districts should be achieved with renewable energy source. So this reduction of fossil fuels contributes to the climate neutrality, and also the PET, in fact, themselves, as they can decrease our surplus, can be used by other districts, but that could not implement this kind of clean solutions, also could help to the neutrality of our city. So maybe in the future we could talk about positive energy cities, but by the moment we are talking about these positive energy districts. So, and this has been what our cities have done. Next slide, please. And for talking about how our cities have been worked, we have today 3 speakers, all of them focused on PV solutions, because sure, solar energy is one of the main energies to be considered in these PATs and positive energy districts. And we will have Clara Lorente from CIRCE and from NEUTRALPATH from Zaragoza side for talking about how these PV solutions have been integrated in the city. Later, we will focus in Turku experience with Hugo Huerta about how this energy can be managed. So apart from being instrument, it can be managed with other into energy solutions. And later, with Hadrien Rouchette from Dijon métropole, we will talk about how we can replicate in other parts of the cities what we have done in one of the districts. So this would be summarizing what we have done. So now I would leave the floor to Clara Lorente for talking about the experience in Zaragoza.
Hello, Clara. I think that your mic is off. We can't hear you. Maybe I can open your microphone.
Hello, can you hear me now?
Yes.
I'm sorry, I was having problems with my microphone.
It's okay. Thank you.
Thank you very much for having me here. I'm Clara Lorente from CIRCE. I'm project manager for the technical part in Zaragoza demo site from CIRCE. And well, I'm here today to talk about how photovoltaic has been integrated in Zaragoza Positive and Clean Energy District. And well, I will focus mainly on the PV integration in one of the buildings that forms part of the district. Next slide, please. I will begin with a short overview of the district. In Zaragoza, we have 6 buildings that are part of the district that is going to be positive and clean. Nowadays, we have all the buildings that are provided with gas for heating and domestic hot water services. We have 2 big buildings that are residential, one school that has that is composed of 3 buildings, and then we have a nursery, and all of them are now well provided with fossil fuels, with gas. So our intervention, next slide please, focuses on first changing the energy sources to all electric district. And to achieve this, we are implementing district ring that is geothermal. So we are taking water from the soil and then using it as a source for heat pumps that are water to water, and that way we can provide heating and domestic hot water for all the buildings in the district. These heat pumps that are electric will be using the energy that is locally produced in the PV panels that will be placed both in the roofs of the buildings that are part of the district and also in the facades of the residential buildings that are the ones that you can see in the upper part of the image. Those are the red buildings. And well, this PV integration is well, the most interesting part, I think, it's the PV that is integrated in the facade. So I will focus my next slides on this. Next, please. Yes, so the PV integrated modules are part of the new facade of the building. we are using PV panels that are provided by one of the partners of NEUTRALPATH projects, that is Onyx Solar. And well, the action is to install these panels in a vertical positions in the facade of the building, and it has been chosen placement for these panels in very specific parts of the buildings where this is technically viable and aesthetically appropriate in terms of the owner's perspective. And well, the panels are next slide, please. A commercial product that is prepared to be installed as a ventilated facade. This is here the technical sheet of the panel. It mainly has well, a power per square meter of 140 watts per square meter, and in total we are going to install 1,800 square meters in all the building, which will make around 800 kilowatt hours throughout 1 year. You will see that for this specific building, it has been chosen to install the panels in every well, in every side, and not only in the south facades. And the reason why is mostly the architectural integration of the panels. So we will assume that one of the some of the panels will produce more power than other. But this has been decided because well, architectural integration has been an important part of the solution. Next slide, please. Why should this be implemented? Well, these kind of panels allow for an innovative ventilated facade solution that is well, that can combine an electricity production with a facade element, you know. So if you choose this kind of technology, you can adapt and install this kind of renewable solution into an element that otherwise you will need to install anyway. So you are solving two things with only one product. So that way we can combine facade finish and electricity production, and less materials are needed. So we have a relative lower embedded carbon footprint. And also these panels can allow things like shading on the thermal envelope, which is really important in southern countries of Europe. This can reduce cooling demand up to 50%. This depends, of course, in every building, but this is one of the main things that are interesting. It can also filter UV light and infrared light radiation while being transparent to visible light. So it can be placed even in front of a window and still allow for views to the outside. These kind of panels use an identical substructure to other ventilated facade solutions, so it doesn't need to have a special substructure options, and the size of panels are adaptable, so it can be flexible to different kind of facades. Next, please. yeah, here we have some built examples of this kind of ventilated PV facade that has already been implemented in other buildings. We have examples in Spain, for example, in Huesca, that is in the northern part of Spain, and also we have examples in Mexico as these PepsiCo headquarters that are located in Puebla. Next, please. This kind of PV facade can also be integrated as a non-ventilated facade, and here we have some examples of this. For example, the Dubai frame building has this kind of facade that is also photovoltaic, and also it can be used as a refurbishment option. For example, we have here an example in Nigeria that was used to refurbish an office building. And next, please. Now focusing on lesson learn and challenges. Well, we had here in Zaragoza an emblematic building. It is not protected in terms of heritage or anything, but this was designed by well-renowned architects in the region, and there was a concern about how to place this kind of facade in this emblematic building that has a special use of brick and everything. And well, the architects and the building owners reflected widely about this, and finally it was decided to place the PV panels in these kind of towers that are located in the four corners of the building, which contains a stair. Please, next. Yeah, we have here the floor plan of the buildings, and then like a zoom of one of the square, one of the corners. So you can see that these corners contain a stair and an elevator, and have two of the walls that have no windows. So the architects decided to place the PV panels in those corners that were like a singular part of the building, and that way we allowed for the install of this PV solution that was innovative, but well, in a manner that was as correct or as well, it was the easier way to maintain the overall look of the building without interfering with it a lot. So next, please. Next slide. Yeah. So yeah, another thing that was seen that was that there was it was complicated to allow correct integration with the existing windows if the PV panels were placed in one of the facades that had a lot of windows and terraces and everything. So by installing them in the parts that had no windows, this was easier. Another thing that was challenging was that as this is provided in the context of a European project, the PV glass manufacturer only provides for the photovoltaic panels, but does not install the solution. An external structural solution is needed to install the panels, so we need to find who is going to provide this structural solution. We need also an installer for the ventilated facade and an electrician that installs this kind of solution, which is not, as it is innovative, it's not common to find. And also, as it is a refurbishment, we need to test we need to test the facade characteristics in terms of strength for the structure to be connected to the original building or the original facade. So we need to have an integral solution that needs to be safe in the Zaragoza conditions that are especially extreme in terms of wind. So all the facade solution needs to be strong enough to be placed in a really windy city. And also, well, as you can see, there are multiple actors involved with this PV facade. So the owner and the architects has concerns about who will be responsible and provide full guarantee of this PV facade integration. So yeah, mostly is this. I think this is all. If you need or have any questions, this is my email, and I will be happy to answer you. Thank you very much.
Thank you, Clara. Yes, don't hesitate to use the chat or the Q&A space to ask your questions. If there are no questions yet, we can directly go to the next presentation with the testimonies from Turku. Please, Hugo, the floor is yours.
Hello, can you hear me?
Yes, hello.
Yes, thank you. Yes, my name is Hugo Huerta. I'm part of the New Energy Research Group at Turku University of Applied Sciences. And today I'm pleased to present you this Harnessing Solar Energy, Smart Management for Maximum Impact project, that part of the Response project, which happens in Turku region. And the agenda for today is going to be as follows. First, a small introduction about solar energy and how this is, what's the status in Finland, and then how we integrate the solar production into the energy management system in order to maximize the PV generation and hence the self-consumption, and also how this aligns with the PV generation or renewable energy generation, and how this align with the sustainable goals. And a few words about the main lessons that we have learned throughout the project, talking about both PV and energy management and how we combine these together. And yes, so first about the city of Turku. Response project had a big impact in this terms, because the goal of the city is to reach carbon neutrality by 2029, and Finland is committed to achieve it by 2035. And in order to do this, well, we have to look at the solar energy, which is nevertheless, it's important in terms of amount of energy that we can produce. Nevertheless, Finland is at the Nordic, it's a Nordic country in which you might think that the solar energy is few, but it is a fact that we have a same amount of energy solar energy produced during the year compared to the north of Germany. Important here is that most of the production is at summer or during the summer months, when we have very long days, up to 19 hours of solar light in a day. And nowadays in Finland, we have approximately 1 megawatt of PV production, and mainly from microgeneration. Basically, small systems connected to the grid. However, there are 24 active solar plants, which total about 100 megawatt. And more important is that we have about 170 projects which are in construction phase or permitting phases, which will allow Finland to reach the gigawatt scale needed. Next, please. Yeah, so how the solar production has evolved, you can see it in the plot. So starting at to show in 2015 all the way to 2023, and the increase of this production has been quite sustained, quite constant, and it is expected that it will still grow in the coming years. So the power capacity, it's around 23 gigawatt, in which the solar makes 4% of this, and 1% of the total energy produced in the country comes from solar energy nowadays. So next, please. There are some, not everything is good news when we talk about solar energy. They have many challenges, and especially, for example, in Finland, when we have very long days, high sunlight, or high amount of solar energy during the day, and very low demand, which is the case in Finland when people, for example, is not in their places during the summer. So all the energy produced mainly has to be sent to the grid in the best case scenario. So this has many challenges for the projects or in the future. And of course, this will, in the cases where we have to send back the energy to the grid, this will reduce the grid strain, voltage instability, because the solar energy is produced depending on the weather conditions. If it is cloudy, it is always fluctuating, and so on. So when there is a lot of production, and it is not in use, well, the self-consumption percentage is quite low, and of course, in the future, this means that we have to curtail that production if it is not any other place where we can use it. So solutions for these problems are mainly related to how we manage this energy, how we can change the way we use the energy produced, basically changing the demand profiles that we have in order to increase these self-consumption percentages. Another solution it is to implement this energy storage systems, which are basically costly still, and mainly they just cover a few percentage of the total production that you can store in the systems. So there are many challenges that we have to consider when we are just thinking about to add more solar power into our systems. Next one, please. And part of the solutions, as I mentioned, is the energy management. Energy management systems are computer-based tools which help us to optimize the energy use basically at any scale. Can be from housing level, commercial buildings, and all the way to industrial operations. They allow us to basically monitor the energy production, control it based on our consumption. If all the data, when it is when the energy management is implemented, all the data is available, and then therefore you can do evaluations in order to optimize your system and make it more efficient and reduce costs. When we integrate the photovoltaic systems, well, we add clean energy into the energy mix, and then we have more systems that requires control, monitoring and controlling. So next, please, transition. Okay. So when we have this energy, solar energy integrated into these systems, of course, we will maximize the benefits, and we are going to have more resilient systems, and therefore, of course, increment the sustainability of these systems. Next one, please. So another important thing that we have to consider here is how we can maximize the PV generation in order to boost the energy efficiency. And this can be done, or mainly when we optimize the design. As our colleague just mentioned, there are many ways that we can, in which we can implement the solar systems. In this case, for example, we are just talking about rooftop solar systems. That's the one depicted in the slide. But also you can consider facades to change the production profile, basically. So this means that, of course, we have to optimize the orientation, the tilt angle, and in general, the full system. But also it's not about just designing or thinking about how much we can produce, or that we have to maximize the production in the zone or in the building. We have to think about also how to maximize the consumption, your self-consumption. Basically, the energy that you produce at the site must be consumed. That is the optimal. And for that, of course, we need to evaluate or do these designs based on our consumption profiles. So consumption profiles, when do you add those to your designs? So basically you can scale up or scale down, modify orientation, tilt angles to the, if possible, of your design in order to maximize their self-consumption. In this case, for example, in the Turku pilot site, the building that it is used is this student village, basically a mixed-use building with about 200 apartments for the students. It includes a gym, a store, and a restaurant. So basically, it has more. Consumption demand is high, and it has a specific low profile that we were using in order to do the design. The PV models here were designed by a local company, mainly based on bifacial cells, and also they were manufactured and commissioned by the same company, local company, as I said. The total capacity of the building is about 142 kilowatt peak, and the estimated energy yield is about 130 megawatt per year. Okay, next slide, please. So another thing that we were considering during the project is not only thinking about optimizing the design and maximizing the production, self-consumption, but also we wanted to go further by adding to the energy management system, which we're going to see more in detail, 2 features, like the prediction of the PV production for the next day. And for that, for example, you can see at in the first figure to the left, a representation of the model that we have on the building. It's a very advanced model in which we are using data from the Meteorological Institute, which basically provides us the irradiation and the weather data for the next day. So we can predict what's going to be the energy production. And with that, we combine we combine it with another feature that we have integrated into this system, in which we try to forecast what's the production of the what's the consumption of the building for the next day. For this, basically, we need to have historical data to predict what's going to be the next day consumption, train the models, and of course, challenges are that for new buildings, probably you don't have that data in order to train your models. So, but as we collect data, we are improving the methods of the models in order to come up with better results. So next one, please. So with this, we can enhance, of course, the self-consumption when we are, when we know what we are going to produce and what we are going to consume. And with this, of course, we are going to reduce the energy demand from the grid. And of course, we are going to reduce that all those problems related to selling or sending back electricity to the grid. But still, we need more systems or more solutions to be integrated in this case, because it's not only, we still have the problem about overproduction. So another solution is, of course, to include energy storage systems and also share that production, that energy, extra energy that we are producing locally with the buildings at the site or neighbor buildings. So this is part of the project as well, in which next slide, please. So in the next phase, or in the next solution that was applied here in Turku for this pilot site, is to add a local low voltage DC nanogrid, about 700 volts grid, which allows to connect or interconnect 5 buildings. So the Tuzia one, the rounded or elliptical one at the right, with the 4 retrofitted buildings at the left. So these are interconnected, and they are able to share power between those. As you can see there, the 4 retrofitted buildings, they have their own photovoltaic system, approximately 25 kilowatt peak per building. And they have a energy hub bidirectional, in this case, which allows you to go from AC, DC, or the other way around. And also a big energy hub in the Tuzia side. So basically, those energy hubs allows you to do that power sharing between the buildings. And part of the energy management system, which is under test still, as the monitoring phase just started, is to integrate all what I have just described. The forecasting methods that we have developed to create new schedules and to predict what's going to be or how we can control the energy use for the next day. So next transition, please. So in this case, there's a small representation about the system. Basically, it consists of, in this representation, the left side represents the physical connections, basically grid, PV systems, buildings, and the battery system. Sorry, if you can go back one slide, sorry. Another thing that I forgot to mention here is that a battery energy storage system was integrated into the 𝐬𝐭𝐤𝐳 building, and it has a 50 kilowatt-hour capacity. Okay, so sorry about that. That is why it's represented here. And all this physical system is, of course, connected with the energy hubs and a server located in TUAS facilities or TUAS University. We have the energy management system, which basically communicates with the energy hub and some of the other separated systems like the buildings. And it retrieves all the data that we are allowed to record and store into databases, as it is PV production, weather from the Finnish Meteorological Institute, energy consumption, electricity prices, and so on. So with all this data, we are allowed to, or we are able to do the load and solar power forecasting, and we try to optimize the energy use based on all that data that we have available to come up with the energy use for the next 24 hours. Once we have that, this schedule calculated 1 day in advance, so it can be just passed to the energy hub, and for example, the battery usage can be just controlled based on that schedule. And then, of course, what to do if you want to buy, for example, or recharge your battery during the night from the grid, for example, if prices are low, and that is also possible. So there are many features that, or capabilities that you can just create based on your needs. If you are interested in maximizing the self-consumption, you can do that. Or if you are, if you want to maximize the or minimize the electricity costs, that can be done as well. So next slide, please. And this, well, this aligns quite well with sustainability goals. We just described some of the goals at the beginning, or the targets that Turku and Finland has or have in this case. And well, about renewable energy, it is expected that by 2030, renewable energy is 51% the total. There are some other specific goals about the electricity and heating and cooling and transportation, but those are just some other numbers that might be related with the PV production or new renewable energy production in order to maximize it. The solar capacity is expected to grow by 2030 by about 5 gigawatt. And for example, the micro generation, like systems that we just showed, for example, they grew 300 megawatt just in the last year, 47% increase just in 2023. And the growth is exponential, as we saw in one of the graphs. This, for example, this picture that we have here, it shows buildings next to 𝐬𝐤, or the building, elliptical building that I just showed. This is called the 𝐬𝐿. And in here, this system is also part of the response project, and the buildings at the rear. And basically all those buildings already have the PV productions. So microgeneration will take a big share of the renewable energy production, in this case in Finland. In particularly in these two cases for the buildings I just showed, to see and retrofit it. So, for example, in the PV production covers, it is still an estimation because we still don't have a full year data measured, that it will, or at least produce 9% of the total consumption. And the battery will take 1% of that as well. For the retrofitted, it is expected that the PV production is covering 8% of this total production. So if we think about that every single building can cover that amount of power, basically these are really, really, or particularly Tusia building has very big consumption. As I said, it has about 200 residents plus the restaurant and the gymnasium and so on. So we are talking about the power demand of 300 kilowatt per hour when it is in its maximum. So it's a big demand. So if we can cover 10% of that, well, that's okay. That's really great. That's a big achievement. So next slide, please. So all that brings me to the my last slide, that in which I want to share the lessons that we have learned in PV and energy management. And first, about the PV systems, then we have to really consider maximizing the cell consumption. And it is just not by designing the system, but also including the load, historical load, and also, of course, run simulations in order to, maximize these benefits. We can also add like some systems in order to maximize it, like the batteries and this power sharing, to, of course, avoid that extra generated power goes into the grid and then cause the grid distresses. And in the future, as we saw, that there will be a lot of power production from solar power production, then for sure there will be a need of curtailment in the future, where you have to shut down plants in order to avoid the stress to the grid. So besides about the energy management challenges, of course, the integration of the systems is really challenging. Many parties involved, different companies, different ways to work, different systems in general, and collaboration is essential. This always flow or interchange of ideas and challenges must be brought to the table and agreed even before the systems have been implemented. Because once the systems are implemented, it's even more challenging. So all those things must be addressed in advance, like the standardization of the communication between those. And data availability is crucial. Like I said, historical data, if it is available, it's always useful. And also when you are generating your data, it's also crucial that you take the data from most of the systems, you store it in a place, and then you are able to analyze it and process it. And of course, there are challenges about the systems. When you collect the data, because there are shutdowns of the systems, we lose data. And in general, data management must be considered. So with that, I want to finish just by saying thank you for listening. And if you have any questions, I'll be more than glad to answer them. Thank you.
Thank you, Hugo. I don't see any questions yet, but again, don't hesitate to write it on the chat, and we'll save some time at the end of the webinar to answer all of your questions. So now, thanks again, and I will give the floor to Hadrien Rouchette from Dijon Métropole.
Hello everyone. Thank you, Liz, for
Hello.
giving me the floor. Thank you everyone for joining for this webinar today, and I'm glad to be speaking about our project in Dijon, which is the response project again, and with the specific conditions of Dijon Métropole. Let's talk about our district first. As you can see, it's a district of larger buildings. With several owners. We have 3 owners of the buildings of response. We have the city of Dijon as such, the municipality, and we have 2 social landlords, so social housing companies, which are Grand Dijon Habitat and Orvitis. So one of the specifics of the response project in Dijon is that we have 3 different owners with 3 different goals and constraints in the scope of the project. What should be highlighted here is that we also have shared knowledge, because some solutions are common between the various buildings of the district. We will go through not all of them, but we will focus on the specifics of the solar production in those buildings. And in the end, I'd like to give some explanation about the replication potential of the solutions that we have tested in the scope of response. Can you show the next one, please, Liz? So in a nutshell, we have the goal of the energy positivity in the Fontaine-Douche district. To this end, we multiply the solutions. As I said, I won't be going through every one of those solutions. I will focus mostly on PV production, but just for you to know, these are not the only solutions that we have. In particular, the raise of renewable energy production is by half is due of this raise, half is due to the electricity PV production, but also half is due to the renewable heat production. Next, please, Liz. I'd like to give a few indications about our works regarding the solar production in Dijon. So first, start with the city-owned assets, which are mostly the schools and the step stadium. That's not the only ones, but those are the ones on which we have PV power, which will be used in the scope of self-consumption. So it means that the electricity is as much as possible consumed directly in the building on which it is produced, so the schools or the step stadium. But as you may have noticed, the PV coverage of those buildings is large. As a consequence, those buildings will produce much more than what the electricity consumption is during the whole year. So for the schools, it's 6 times their own production, and the step stadium produce many times more than it actually produces. So as a consequence, those excess of production, those surpluses, will be shared. They won't be sold. Instead, they will be shared with other sites. And as you can see on the bottom right, those sites which have the same owner, so the city of Dijon, will be able to consume this excess production of electricity on those 3 sites, and to be shared with 21 other sites, including the swimming pool, for example, or other schools. So it is a good thing for the savings of the whole city, not only of the schools inside the district. Can you show the next one, please, Liz? In order to reach the energy positivity, we also have other sites which will get PV production, and to this end, we aimed at road and parking sites for which we do not have electricity consumption, and for which we will produce more or less 1 gigawatt hour per year. This is a large production which we wouldn't have been able to consume directly in the local buildings. So those sites are not in self-consumption. Instead, they are in total selling of this electricity to the market. So it is interesting to have both, because we have the self-consumption for sites which can actually absorb this large consumption, and sites which are full selling in order to be able to sell it properly without relying on the self-consumption. So these are also 3 large sites of the city. Let's go to the social housing companies now. We have 2, and those 2 have pretty much the same solutions. Where again, I will just mention that we have a production works dedicated to the electricity, the energy savings, both for electricity and heat. But we also have an innovative solution of PV production on both Grand Dijon Habitat and on Orvetis roofs. For those, we will have solar pergolas over the roof of the buildings. So 2 buildings on Grand Dijon Habitat and 1 in Orvetis will get those pergolas, which bring us several benefits. The first one is to have the panels located not on the roof, but above the roof. As a consequence, we can have a larger coverage of those PV panels, because we are not in competition with other usage of the roof, which is not having a barbecue with friends, but it is about having the use of the ventilation systems, the elevators, and so on, which have services on the roof of the building. So those systems would be in competition with the PV panels. In this case, those PV panels are located above, so we can have both at the same in the same place. So it brings more production. And if we can go to the next one, because what I will be saying next for Orvetis, yeah, nice. Thank you, Elise. What I will be saying is true for Orvetis as well, for both Grand Dijon Habitat and Orvetis. The business model is that the social housing companies will be investing on those systems, and those systems then will provide electricity to the common areas of the buildings, such as ventilation, the elevators, the lighting, and so on, of the shared spaces of the building, which will reduce the payments from the tenants. What is not consumed will also be shared with the tenants for their own electricity consumption inside their dwellings. So they will have two wins: one on their payment for the landlord, which will be reduced, and one for their own electricity bills, which will be also reduced. So they will win on both sides. Finally, in addition to those pergolas, which are located above the building, we will be able to have 2 strips of vertical panels, which will be tested on the roof of the building of Grand Dijon Habitat and Orvetis, which will make it possible for us to test the efficiency of bifacial PV panels located vertically on the roof of the building. Can you go to the next one, please, Liz? Yeah, what we learned, from this process was that we have been able to create in economically viable systems, which we'd like to then reproduce on other sites of Dijon, and it will be the main subject of the end of my presentation. We'd like to know more about our capacity to integrate the people in the self-consumption operation, but we guess that many people will jump in, as it is a win for them without any counterpart. And we are testing the system of management of the energy management at the scale of the whole district, and we are starting the monitoring of this system, and we'd like it to be to be a tool for the future in creating new positive energy district, and also to manage future positive energy districts in Dijon. Regarding the challenges that we still face, in addition to economy, for which we found solutions, one of the main barriers for us was the regulation in France, where we have in France a strong focus on the security in buildings, so it is hard to integrate innovative solutions. So we are working on it in order to improve this and to find workarounds and proper solutions in order to be able to integrate innovative solutions. In addition, we also had difficulties regarding the economic viability due to the volatility of the energy and materials prices, which have made it very complicated to give security to the housing companies and the city of Dijon, which would be investing in those systems. And finally, something which is very important to us in the cities regarding the positive energy districts that we are building is that we have a focus on the energy efficiency through innovation, which is a very good thing, but we also have now to integrate also innovation for the operational security. We need to have those systems more operational, because it is not the same in the laboratory as it is in real life conditions for tenants who are not actual partners of the project. They didn't sign for it. So we need to bring them security in addition to energy efficiency. It should be a strong focus for us in the upcoming projects. Can you go to the next one, please, Liz? Because regarding the next projects, I think I'm running out of time, so I will be quick on this. But just for you to know, we are looking at the iteration of the project regarding the monitoring period in order to gather results regarding the production and the energy savings of the response project in Fontaine-Douche, but also on the impacts, the social impacts on the citizens. And then we are starting the work on the replication in other districts of Dijon. And let's look at it. Liz, please. For this, we have in Dijon Métropole created an organization which we call FAST, which is dedicated to be the operator of the energy transition in Dijon. So it is a broader vision than a response, but response was the spark which lit this system. The idea is to gather the local partners with whom we are already used to be working in order to work together and find synergies in the projects for the energy transition. So our main direction is to work with the climate and energy action plan and the climate city contract, which has been created in the scope of the 100 mission cities in which Dijon Métropole is involved, and to go further by creating a governance operator, which makes it possible for the partners to share their project, what they want to do, and to share the results of those projects. And also we will be creating engineering organization which will help the local partners to create more of those projects without having to recreate those from the very beginning each time. It makes it faster and more cost efficient to work this way. And let's look at the progress on this, as it is another project, but again, response was the spark in order to create this. We have mobilized the partners, those partners who are either municipality or the larger energy producer of the territory, or the energy consumer of the territory. All of those are now joined with the same goals in the scope of the FAST project. And now we have identified also an organization which will help with the financing, which is one part of the project engineering, which is not only about choosing the technologies, but also in finding the financial ways and frameworks in order to be able to create those projects. And now the things which remain to do is to share the climate energy platform, which is a monitoring tool which has been created in response, which is operational but has to be shared with the local partners. So this is aimed at next summer. And finally, the actual organization of the territorial engineering organization is still ongoing in order to be started in June 25 and to be able to help the local partners in starting specific projects, which could be joined between several partners instead of each partner running on their own project. That's our goal, and we already identify partners who are interested in working this way, in working together in order to buy in bulk or to co-organize some solutions which should benefit to more than one partner at a time. We already have those organizations ready to work with us on this. So I will stop there, and I think there is time for questions. I hope still.
Thank you, Hadrien. Indeed, we have some time for questions. I don't see any in the chat. Please don't hesitate also to raise your hand. I see that Claudio raised its hand, so we know you, Claudio. I will just allow you to speak. Is it okay?
It's okay for me.
Hello.
Thank you for. Yeah, it's been a very interesting presentation, a series of presentations. So probably I hit the hand by mistake. Please do excuse me for that. And but
Okay, no
I'm
problem.
open to your questions to me.
Thank you.
I thank you. Thank you very much, Lise.
So I can still give you a few minutes to think of your potential questions and I will. Monjur, do you have a question?
Yes, I have a small question to Clara.
Hello.
Thank you for your presentation. I could remember in your last slide you mentioned about the involvement of different actors in providing the PV solutions on the residential building. We know that it's very complicated because you need to involve basically series of stakeholders. So at the end, when you are going to implement or install the PV solutions on the buildings, what are the technical and regulatory aspects taken into consideration in Zaragoza? Just to give an example, for example, you are putting the PV on the residential building, and the building is probably owned by the city, right? So when you are going to install the PV solutions, what are the mechanisms involved? Are there any need of certification from an authority who says, okay, these PVs are very good and you could put it? Do you need sort of insurance against that? So could you please explain in this regard?
Yes, so the PV panels are a commercial product right now. So for the photovoltaic glass, it's all right. It's more related with the practical problem of, okay, we have a provider, but we don't have an installer that provides like the constructed solution as a whole. So we need to find an installer that wants to, provide a warranty for the building owner of the whole solution of the facade that is installed by them, but the glass that is provided for by another entity, and then we need an installer that is both a ventilated facade installer and also an electrician, because it's a physical element but also it's electricity producing element, which needs appropriate engineer to provide a certification for all that, and so on. And of course the architect is concerned about installing something that is that involves that much actors, because if in the event that there's a problem, it's always more difficult to find who can solve this problem or who gets responsible of which went wrong. So yeah, we find that in a practical way, this kind of multiple stakeholder solution, it's always more difficult to implement than for example, conventional PV modules. That is something that we can find installers in the market that provide the whole package. So yeah, we're working on that, and it's something that the building owner that is a public company will have to reflect in the contract with the construction company that implements the solution.
Thank you very much.
Maybe one question to Hadrien from Dijon Métropole. I was wondering, how do social landlords recover their money in self-consumption operation, as well as the schools?
If I understand well, you are talking about the economic point of view. There is an investment which is done by those actors, and how do they retrieve the money back? The easiest way to explain this is for the schools. So in the city assets, there's two ways the city gets money from these investments. Is either there is electricity sellings, so there is investment from the city. The electricity is sold. This create earnings, and those earnings will compensate over the time the initial investment. The second possibility is in the scope of the self-consumption operation of the city. In this case, the reduction in the electricity bills of the city will then create earnings, as those are savings in comparison in the case where the city wouldn't have done these investments. For the social housing companies, it's pretty much the same, but there is a little specificity in the fact that the social housing companies, when they save electricity from the shared spaces, the common spaces of the buildings, they reduce the electricity bill, but it also reduces the payments from the tenants. So those are immediately compensated. It's a full gain for the tenants. As a consequence, in order to get their money back, they have to have a share of this electricity, which may be sold if necessary. But the main thing will be to ask the tenants in an agreement to participate financially to the investment. And the rules in France is that it is doable as long as the benefit for the tenants is guaranteed to be positive. So even if there would be no electricity for the individual consumption of the citizens, only for the common spaces, the payments from the tenants to the social housing company will be less than what will be saved due to the energy savings in the common spaces. So whatever happens, the citizens will be the tenants will be winners in this case. And we've studied a lot in order to make sure that everyone will be a winner in this case. So by saving energy, reducing the bills, and in the case of the social housing companies, there is transfer of money from the tenants to the social housing company in order to compensate a part of the initial investment. This is one of the innovative learnings that we have in the scope of this project, because we don't have many of those operations in France currently operational.
Thanks, Hadrien. I don't see any more questions. Maybe Monjur, as a coordinator of the Response Project, you want to give a few words of conclusions to this webinar?
Yeah, sure. So first of all, thank you very much to all the presenters. It was really a great discussion on the PV solutions. So PV is one of the many solutions for our roads towards the climate neutrality. And we have learned a lot today from two different projects. And we had a lot of examples in 3 different cities. They are very much different. We saw Turku, we have less sun in the winter time, but more sun in the summer. Dijon and Zaragoza are more or less on the same climatic conditions. So this is really very good learning for all of us. And we also learned different examples of PV solutions. We have the rooftop PV solutions we saw in Turku and in Dijon, and then Clara in Zaragoza explained about the building integrated PVs, which is also very innovative. And we also experienced different parts of this PV electricity generation. For example, we learned the PV generation options, especially regarding the BIPV and the experience in Zaragoza, and then also in Turku and in Dijon. So that was really good to know. And then Hugo gave a very good example of the PV management through the to optimize the self-consumption. Because if there is any surplus, for example, as he mentioned during the summertime, so we had to save it and then distribute it. So it was very good to know. And then Adria also give a very quick overview on all these aspects of generator production management, and also how we could replicate these solutions, for example, within the Dijon's ecosystem further. So this was a very good learning for all of us. I should not also forget Cecilia. She also gave at the very beginning an overview of PED concepts. We know more or less what PEDs and PCEDs, but she also gave a thought on how solar is important in reaching the clean energy within the cities. And I would like to also thank to Liz for her moderation. It was really good to have all of you here and to talk about one particular solutions from many other solutions, which probably we will talk in future. And I think that's all from my side. Thank you very much once again.
Thank you, Monjur, and thank you all. Don't hesitate to reach us by email if you have any questions coming later.